Hello, can you hear me? Okay. I have no audio. Wait a moment. What about now? Audio. Yes? Okay. Let me see. We have Corbin, Rawa, Haji, JC, Aaron, Savan, Christian, Muhammad Howdy, Manny, William. So let me see. I think everybody is here. Abdullah Gandhi. Abdullah Gandhi. Abdullah Gandhi. Yes? No? All right. Before we start the new material today, any question about the midterm coming up next week? Yes, midterm is next Tuesday. Next Tuesday. All right, so let's get started. So today we are going to look at how to design circuits with multiple state machines because next assignment you need to work on multiple state machines. So this particular example I'm going to work on in class is going to be two state machines. So remember, for the next assignment you should design 4 digits. So now I'm showing how to design 2 digits. Okay. So what I did was I create a brand new project. Again, I always call it design zero. And I have a reset, I have a clock, I have digit one and digit two. And then they are 4 bit each. The reason it is 4 bits because you need to go from 0 to 9. Okay. So from 0 to 9 you need 4 bits. So don't worry about typing. We are going to do this very slowly. So the library section is the same. The entity sections you need to change. So what you should do right now is you should start a brand new project and modify the entity. Okay, modify the entity because I believe your existing project has already uh, had the correct library section because we'll be using the same library for many projects. But the entity section is different. So now you need to change your entity. You have reset clock to outputs. Okay, so do it now, please. Let me know when you finish typing. Okay, that's great. Yes, you need to have the digits going from 0 to 9, but not all the digits will go from 0 to 9 because, for example, for the minutes, one digit go from 0 to 9, the other digit go from 0 to 5. Okay? The seconds, of course, go from 0 to 9. Is Douglas here? Or then typing? Everybody else? Okay. If you're still typing, no problem. I'll post the new section of the code so that people who already finished can continue. Right? So the next thing is to define the states. Now, if you look at this code right now, I only have 4 states. But we know that we need more than 4. Why? Because we need to count from 0 to 9. So that means I need to define the state this way. Okay? So I'll have all the digits 0 through 9. Yes, stop. I got you. So everybody's in today. That's good. It is not hard. You need practice. That's good because you're working. Yes. There's a tutor you can set up fun with. So besides visiting the lecture, you can also ask help from the tutor. The instructions are posted on your You can put in the appointment request, and then they'll do a one-on-one live, like a Skype or Zoom. Are we done typing? Yes, he's a graduate student from the program. Are we done typing? Okay. So these are the states that you may have in the design. Uh, Once you define this, it doesn't mean that you have to use all of them. It just means that some state machine inside the design may go through 0 through 9, some may go from 0 to 5 or to 6. Then it's totally up to the design itself to determine which state you're going to use. Okay? Alright. So next thing is we have two state machines because they're two digits. So we need to define the signals that will hold the state. Usually there's only one, but in this case there are two. So we have to do this. We define current state for digit 1, current state for digit 2, next state for digit 1, and next state for digit 2. Okay? And they have to match the size because your states is 3 down to 0. That means your signal must be 3 down to 0. Okay? So please type this in and let me know when you're done. Oh, by the way, is Christian here? Is Christian here? If you are here, please answer me. Okay. All right. So make sure that these are the signal for the state machines. Let me know if you have finished typing. Anybody else besides Aaron? Okay, that's good. So now the next thing is to define the processes. If you remember, a state machine requires three processes minimum. One for state transitions, one for next state evaluations, one for state outputs. Since we have two state machines in this design, it means we have six processes. So we're going to start with digit one first, then we move on to digit two. Understand? So the process number one is this. I'm sorry, process number one is this. Let me show you the code. If you have a reset, state will go to count zero. That makes sense. When you reset a counter or reset your clock, it goes to zero. Next one is if you don't have any reset, every time there's a clock, the state machine goes from next state to current states. So that means you advanced in time. Okay? So please type this in. So now we're at line number 52. We need to finish line number 52. This part is the reset plus the state transition. Okay? You cannot separate the reset from the state transition. You must have a reset. Okay? So process number one, you have this. It takes care of the state transitions and the reset. Process number two is next state evaluations. Okay? So first, we need to know this is the state machines for digit one. You should go from 0 to 9. Okay? 0 to 9. If you are at 0, you go to 1. If you are at 1, you go to 2. If you are 2, you go to 3. 3 go to 4. 4 go to 5. 5 go to 6. 6 go to 7. 7 go to 8. 8 go to 9. And then 9 goes back to 0. That's the sequence. Okay? And there's no clock in this process. So if you look at the code, process number two looks like this. So you're looking at current state, then you look at what are the possible combinations for the current states, and then you go to the next state. So you can see that 0 go to 1, 1 go to 2, 2 to 3 to 4 to 5, and so forth. And the others, which is default, it goes to 0. Okay. So please finish typing line number 71. That's where we are now. Line number 71. Are we done typing? Okay. Okay. All right. So the next process is the output. So we'll have process one, two, and the next one output. Output is very simple. Now, this particular example does not deal with the hexadecimal display. For your assignments, you need to output to the hexadecimal display. Understand? So you cannot use the example as this. So the example is just showing that, hey, right now I have digits. I want to see if they are going through the count correctly. Okay? All right. So for output, you have these. There's a clock, and there is a clock, and there is a reset. So you can reset the output zeros. Otherwise, you're just going through the binary combination 0, 1, 2, 3, all the way to 9. The default is 0. Okay, so right now we're up to line number 95. Let me know when you finish typing. Okay, we have three people finished. Anybody else? There's no reason. This is a demonstration. This will show you how to design a circuit with multiple state machines. When you look at your assignments, you need to output it to the 7-7 display. Are we done typing? Yeah, I assume that you guys all set with typing. So you need file, save. Okay. So right now we have completed three processes dedicated for state machine number one. And we can check the design to make sure that so far we don't have any syntax error. So processing. So before we do that, file save project. Processing, processing, start, analysis, and elaboration. So you're just going to go through the syntax and make sure that you don't have any missing semicolons or missing keywords that's supposed to be there. It does not deal with what's going on inside the logic. Okay? This is not complete design because we're still missing the processes that will control the second digit. Okay. Okay. No error. That's great. So make sure that you do the steps. You shouldn't have any error. Yeah, the internet. Remember, right now The antenna planner is using internet at the same time. When it lags, there's nothing I can do. I can post the code after we finish this. I cannot post the code while we're doing this. Okay? You need to type faster and use the copy and paste because you can see that a lot of these lines, they're almost the same. They're also off by 1 or 2 digits. Learn how to use copy and paste. Alright, so now if you look at the code, we have 3 processes, P1, 2, and 3. In VHDL, you can give labels for each process. This is very useful because if you have a design that has, say, 200 processes, when you review your code, it's impossible to figure out what's going on. So in VHDL, you can add labels. So for example, for this, I'm going to call it P1. So we know, oh, this is process number 1. This is my P2. And this is my P3. Okay. But labels are optional, but the labels are good because you have larger design. You want to track what's going on between these processes. You want to give a name for each process. It makes the code more readable. It is like writing a C program without any comments. How would you know what you're doing? Okay. So right now we have defined process 1, 2, and 3. This will take care of digit 1, digit 2, and this will take care of digit 1 only. So now we're going to move on to digit 2. So for digit 2, you have 3 more processes. Okay. Um, for digit 2, when you try to make transitions, you're not going to make transitions based on your clock only. The reason is this. Digit number 1 will go from 0 to 9. Digit number 2 will go from 0 to 9. However, digit 2 will only go from 0 to 9. 0 to 9. I'm sorry. Digit 2 can only change value if digit 1 goes from 9 to 0. Understand? So let me repeat this. Digit 2 can only change value if digit 1 goes from 9 to 0. Understand? So that means digit 2 also look at digit 1 values. Look at the state from digit 1. Understand? What do you mean when you're lost? Digit 1 goes from 0 to 9. Digit 2 goes from 0 to 9. But digit 2 can only change value if digit 1 goes from 9 to 0. They're not changing at the same time. Okay? So that means if you want to change your state for digit 2, you have to make sure that digit 1 goes from 9 to 0. Okay? If digit 1 doesn't change from 9 to 0, then nothing will happen. Okay? So that means for your logic, you have to include the state from digit 1 and digit 2 state machines. So state machine number 1 becomes input to your state machine number 2. Right. So look at the code. This is P4. Digit 2 equal to 0 if you have a reset. That's usual. If digit 1 is equal to 9, there's a clock, then digit 1 will go from 9 to 0. At the same time, you can change value for digit 2. So please type up to line number 108. Okay, if we cannot finish typing everything today, we're going to continue this next 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 class. Not the weekend class, but next class. But I don't think we have a problem because we're making good progress. We're only halfway through the class, but we already finished half 50% of the code, which is good. So let me know when you finish typing. Okay? Okay. So I guess everybody is making good progress for P4. So I'm going to give you the P5. P5 is the next state evaluation for digit 2. Okay? So you can see that this is similar to P2. Why? Because you're looking at state machine digit 2. If you are at 0, you go to 1. If you are 1, you go to 2, 2 to 3, 3 to 4, 4 to 5, and so forth. Okay. So again, copy and paste really helps to speed up your typing. So now we need to finish typing up to line number 127. you have completed P5, you should try P6 on your own while waiting for the other ones to finish. Once everybody is done, I'm going to post the P6, and then you can look at your code versus the my code. Okay, that is no significant. This is how the state machine functions. If you change the state machine, you can go from 0 to 5, then 5 to 7. But that's not the intention for this demonstration. This demonstration is to show you how to design two state machines that will interact each other. And the way we do this is we have two digits. Digit 1 will go from 0 to 9, and digit 2 will go from 0 to 9. But digit 2 will only going to change the value if digit 1 goes from 9 to 0. Okay, this is very similar to your assignment. Your assignment has 4 digits. This has 2 digits. Okay. All right, so I guess everybody's done typing P5. So now I'm going to give you P6. Okay, so P6 is the output for state machine digit 2. So this is P6. So output for P6 is digit 2, and then you're looking at state machine 2, output 2. Okay, so finish typing until 154. That's the end of the code. Okay, if you finish typing everything, let's do a file save. Then we're going to check the syntax, make sure that we don't have any error. Are we done? Okay. Again, all these codes, you can see that they're very similar. You can use copy and paste. There's no need to type in every single character every time. Okay? There's a pattern. Once you realize there's a pattern, copy and paste is very helpful. All right. So next thing we're going to do is we're going to compile the entire project. Okay. All right. So let's start the compilation for the project. Let's do a file save project, processing, start analysis and elaboration. It's supposed to go through the code completely because it has everything we need. 2 state machines, 6 processes. Right? No error. Just 2 warnings. Always get those 2 warnings. I think one is from the clock, the other one is how many CPU you have for this project. All right. So now we're in good shape. So we don't need to worry about the pin assignment now because this is demonstration only. We're not going to put it on the board. Remember, this state machine will run at 50 megahertz. For the clock, you're running at 1 hertz. You cannot run at 50 megahertz. You're going to see anything. Okay? All right. So I believe everybody is ready, right? So what we're going to do is we're going to do processing, start compilation. So this will go through everything, not just checking a syntax. Okay? You can see that it goes through everything. This will take a few minutes. Depends on your machine. Okay, if you have error, it's probably somewhere there's a typo. Don't worry, I'll post the code after class so that you can double check it. The goal is not to like type in everything right now. If you cannot catch up, that's okay. But the code will be available on you learn after class. Then you can run it. Okay. So this is syntax error free. You can see that I finished the process. I'm going to start the assimilation because we need to deal with the command files. So I'll post the command files as well as the code itself. Okay. This is the simulation. We're going to do simulate, start simulation, size 0, 1 nanosecond. Okay, so let's start a command file. So the first thing you do, we are going to put the input outputs on the waveform. Okay. So we have two inputs, key 0, which is a reset, and we have the clock. That I try to use different colors for each assignment, so I won't get confused. That's which assignment I'm working on. You can see that the red for the reset, blue for the clock, pink for magenta for one output, green for the other output. Okay, all right. So next is to activate the reset, deactivate the clock. Okay? It's meaningless if you activate the clock and reset at the same time. If you reset, it's going to dominate. Okay, so that's the activation of the reset and the activation of the clock. Let's do that. That's good. Then we're going to activate the clock, deactivate the reset, and then we're going to run it. So each clock is 20 nanoseconds. This state machine will go from 00 to 99. Okay, so we need at least 100 cycles. 100 cycles times 20 nanoseconds is 200 nanoseconds minimum. So I'm just going to run it for 300 300 nanoseconds. Okay, it's going to be way over. I'm sorry, not 300. 100 times 20 is 3,000. Okay. Let's run. So we just ran 300. We're missing 2,700 nanoseconds. Okay. All right. So event. Let's maximize the screen. Okay. Let's look at what is going on here. So let's zoom to everything. Now you can see that digit 2 doesn't change every clock, which is good. You shouldn't be changing every clock. You're supposed to change every time digit 1 changes. So let's go through the numbers now. Digit 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. Okay, so the sequence for digit 2 is correct. So let's zoom in, look at these edges. So now you can see there's a change of digit 2. Let's look at what is going on with digit 1. Okay, so zoom in more. So digit 1 sequence is the pink one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And pay attention here. Every time digit 1 goes from 9 to 0, digit 2 increment. That's the behavior we want. So let's look at the behavior is consistent. So the next cycle. So the next cycle is right here. Digit 1 goes from 0 to 1 to 2 to 3 to 4, 5, 6, 7, 8, 9, 9 to 0, digit 2 increment. Okay, let's check one more to convince ourselves it is indeed working just fine. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 9 to 0, then you have digit 2 change. Okay, alright, so that means this thing works. That's great. That's what we want. So this is what you need to do for assignment number uh, the digital clock one. And also, this one does not output to the hexadecimal display. It does not slow down the state machine response. Okay, so for you, you need to add state machine to response to the 1 Hertz only, and also add the hexadecimal display outputs. Okay, so bottom line is designing a state machine is not hard. It's just that you need to do it systematically. You, you need to divide the task into processes and then do one process at a time. Okay, if there are interactions between state machines, then you need to know where you put in the interaction. Understand? Okay, it's okay. I will post the code after class. I'll post the command files, and then you can double check, make sure it works in your environment. Okay. All right. Okay. So um, this is not due this week. This is due next week. Okay. Next Tuesday we have a midterm. Any question about the midterm? Yeah, the error you have is you cannot change state machine 2 in state machine 1. You cannot change state machine 1 in state machine 2. So when you look at the processes, they're very unique. You cannot have two processes changing the same thing. Think about this. If you are changing this the state machine 1, at the same time you're doing state machine 2, but you're also changing state machine 1. That's not possible. You cannot do that. There's no circuit that you do it. Okay? Okay? Yes. During the midterm, there will be question posted on Uline, and there will be area upload for each question. You have only one attempt per question. Okay? So if you once I post the questions, you can say, well, I want to do number 3 first. Fine, you can do number 3. You can do number 1. It doesn't really matter because they are all separated, independent. Okay? You need to know how to write VHDL. You need to know how to use the software. You need to know how to run simulations in Modelsim. You need to know how to create commands in Modelsim to run simulations. So basically, design assignment number 1, 2, 3, 4. That's what you need to know. Again, this is live. That means you can use your computer. You can use your book, you can use your notes, you can watch a YouTube video while you're taking an exam. I don't really care. But what I care is the exam is live, it's given to you. You only have a limited time, which is from 2 o'clock to 3:30. Understand? All the errors will be timed. So if you miss the upload time, that's it. But it's one questions per upload. You can expect up to 5 questions. 1, 2, 3, 4, and 5. Chapter 1, 2, 3, 4, and 5. Chapter 5 covers a lot, including state machines. However, state machines, that's they covered. We only deal with keywords if, else, and case. Okay, so you don't need to read the chapter page by page. You need to read keywords if, else, and case. Of course, the rising edge. The example we just finished, it's also from chapter 5. Okay, but it's a more complicated state machine. You're not going to see these kind of questions in the exam because it doesn't take 1 hour to finish. It takes 1 week to finish. Understand? Okay. Again, the exam is to test you understand the material. Doesn't mean that you can do a design live. Nobody can do a design live unless it's a two-input logic. Okay, right? You need to know how to use the tool, how to write VHDL, how to use Modelsim, how to run simulation in Modelsim, the commands you need to use. Okay. By default, everything is rising edge driven. So we'll always use rising edge. But you can also have the falling edge. But usually people don't use the falling edge. Okay? Alright. But if you don't have any question about today's assignment or any question about the midterm, I'm going to terminate a live in a couple minutes. And this code will be available after class. I need to get ready for the next class. Okay? But if you look at the code is very clear what's happening. We divided the task of the state machine into processes. And each process do a piece of it. It is very organized. Okay? And also, when you have multiple state machines running, you need to know which state machine is affecting which state machine. So, for example, state machine for digit 1 is affecting digit 2, not the opposite way. Digit 2 doesn't change state machine 1. That's why line number 104 is important because this tells the software that I only want to have a change in state in digit, for digit 2 if digit 1 changes from 9 to 0. If it doesn't, I'm not going to do anything. That's why we have this behavior. Okay? All right. So, any questions? No? I'm going to close this, save my command files, and then I will post everything after class. All right. If you don't have any questions, you can leave the live. Okay? No, the requesting for tutor help is not done via ULearn. The instructions to request tutor help is on Ulan. There is a procedure you know follow. I think it was making a phone call, tell you what date, and then make appointments. Then they will give you the link for the tutor service. Okay, so just go to Ulan and look at the post. Anybody else has questions? Okay, then we're going to finish now.